The seventh question from Electrostatics, dipole, and a very straightforward question. The electric field and potential due to a dipole has been asked. Let's say a point dipole, the magnitude is P naught and directed along negative x-axis is kept at origin. We need to calculate the potential and the field due to this dipole on y-axis at a distance d. Essentially, we need to calculate the electric potential and the field due to this dipole at equatorial position. So when we say equatorial position, the potential has to be 0, right? So if potential is 0, then option 1 and option 2 would be eliminated, because in the pair, the first one is the potential. So 0, 0, that's fine. And now effectively, I need to calculate the electric field, and we know when it comes to the equatorial position, the direction of electric field is opposite to that of the dipole moment. Therefore, option number 3 would be the correct option. And the value is very straightforward, Kp divided by d cube, K having its usual meaning. So option number 3 is the correct option for this. Time to move for the next question. Question number 8, again something related to device, instrument and measurement. This is what I have been saying, that whenever anything is related to measurement, you need to focus it with great attention. And this topic has been brought from geomagnetism, Earth's magnetism. And that is a topic which is exclusively there only in JEE Mains. It's not there in JEE Advanced. And if you have watched my earlier analysis, I always focus on one thing, that when it comes to preparation of JEE Main, you need to focus on those areas which has an exclusive domain only of JEE Mains. I don't mean to say that other has to be, excluded or neglected, but specifically this you need to give an additional care. Okay, so here see a magnetic compass needle oscillates 30 times per minute. Let's try to calculate the time period. You see 30 times per minute. That means if you want to see one time, how much? Of course, it would be taking 2 seconds. So T1 would be equals to 2 seconds. That's a first one. Then second, let's say 40 times per minute. Therefore, T2 is going to be 3 by 2 seconds. Okay, I calculated T1 and T2. And this is happening at a place where the depth is 45 degree and 30 degree respectively. And B1 and B2 are the total magnetic field due to the Earth. Now, when the compass needle oscillates in the horizontal plane, the effective magnetic field which is there responsible for oscillation is the horizontal component. So in the first case, see, BH1 is B1 cos 45, the horizontal component of the Earth's field, which is influencing the oscillation. And the second case, I believe it's 30 degree, that will be B2 cos of 30 degree. Okay, so here I get the horizontal component of the field at this place, at that place, and the time period has been given. And what is supposed to be found out? Yes, we need to calculate the ratio of B1 is to B2, and we know the time period is 2 pi under root I upon the horizontal component of the field multiplied by the magnetic moment of the oscillating needle. Now, in both the situation, I and M would be same. After all, that's a property of the needle, so that has nothing to do with Earth's field. So you just divide the time period, you would certainly get the ratio. So that goes on a straightforward pattern, and option number 2 would be the correct option for this question. Fine, now it's time we move to question number 9. Question number 9, electromagnetic wave. And this is another topic which is specially reserved only for JEE Mains, and that is not there in JEE Advanced syllabus, which I have been saying quite frequently that we need to pay special attention to those topics which have a special status for JEE Mains. Okay, it says there is an electromagnetic wave, and that electric field component of the EM wave is represented by this. Clearly, we know that this is the direction of the wave traveling, and the wave is traveling in the YZ plane. That's very clear. Now, taking unit vectors as I, J, K, the regular convention, we need to calculate the direction of the wave propagation. Okay, to go for the direction of the wave propagation, I can write in this way. We can compare it as omega t minus of k times r. That's how we go, right? Like when you write omega t minus of kx, the wave is traveling in positive x direction. That's how we go. So here, omega t minus of this, when I do that, I'll be getting the direction of the wave that is equal to, you see, this will be minus of 6j cap plus of 8k cap divided by 10, which is the magnitude of this, and quite obviously by taking 2 common, that will be minus 3j cap plus 4k cap divided by 5. I think that's there in option number 1. Option number 1 would be the correct answer for this. Time to proceed to the next one.